You guys don't know how to solve equations.
Divide by 100.
Divide by 100.
Good job. 400.
Yep. So we're going to get 4,000
Oh, I know how to do it. Cool.
equals 2dx. So then how do we get our exponent to come down? Do what? Do the log. Right? So we do log of both sides. And since we do the log of this one, we obviously have to do the log of this one. The log. Like the. So you take the log of 2 and then it brings us down. Is that, I'm not sure what you're asking. What do you mean, how do you get it? Like, how do you do it on your calculator? So then how do we solve from there? Nobody knows, or everybody is just silent? How do we go from there? How would we get x by itself? What else do we have to do? Divide by the log of 2. So if some of you are doing it and you're just quiet right now, what did you get for your x value? Nobody got it? Evan, what did you get?
11.965.
Okay, so we have 11.965, so that rounds up to 11.97. So it's the same thing as the other answer we got. So just kind of to show you that, yes, we're not using logs yet, but you can use logs for this kind of stuff. If you, even to check what? To show you can solve both graphically and algebraically. And we're going to be using logs, so you're going to have to be familiar with them. We're going to start using them more.
Yay.
Yay, I know. Mitchell, the other day you said something about logs, and so I just thought, just for you, I would talk about logs today. It's your favorite?
No, I said favorite.
Oh. Okay. So, does anybody have any questions on that problem, though? Seems like everybody's pretty clear. So let's move on to the next one. Braden, what? Okay. So, this is a similar one, but it's talking about half-life. Have you guys dealt with half-life before?
Yeah.
Yeah? Okay. So, if we say f of x is equal to what? 600, good, times what? So if we have the half-life of something, we can think of it as every 5,730 years, it's going to be cut in half, right? So it's going to go from 600 to 300 to 1, yep. Okay, so that's why, since it's being cut in half each time, our decay factor is 0.5. And so normally we just add to the x. What does the 5,730 have anything to do with it? So we write x over the amount of years, because if we have, let's say, like 7,000 years, and if you divide that by 5,730, that gives you the number of half-life. So that tells you how many times your initial sample, or the 600 grams, is going to be cut in half. So we want to find out how many are going to be left after 34,380 years. So I want you guys to try that on your own real quick. Try and figure out what you would do. Okay, so what did you guys get? How much will be left after 34,380 years? Say it again. 9.375 grams. And how many half-lives is that? 6. How did I get what? This? So we plugged 3,000 or 34,380 in for X. So if we say that, so let's look. So if we say that 34,380 divided by 5,730. So we said that was 6 half-lives, right? Aaron, do you see that?
Yeah.
So then we take 0.5 to the 6th power. Oh, you get it? Okay. Okay, so what about how do we find out when there's going to be 20 grams left? Graph it. So what do we graph? What do we want to set equal to each other? Yeah, we want to find out when our function is equal to 20. So yes, we can graph it. Talk to Sharphorn. Not during class, though. He doesn't expect you to leave class. Just wait a second, Jack. So we're going to have another big window in here. What has to be bigger here, your X or your Y value for your window? X, right? Because we're looking for when Y is going to be 20, so we don't want our Y to be really big. So mine looks something like this. Is that what you guys got? What? So who found something? Raise your hand if you found what it was already. Only one of you found it so far? 2 of you? Okay, so let's try and let some more people get it then. Yes, won't you get something different if you don't? So if you didn't do, for your X one, if you didn't have X over 5,730, you will get something different. I don't know, I'll tell you in just a second. don't think you got it right?
I know I got it.
Okay. So it should have been about 28,116.5 years. Is that what you guys got? No? Did you get a graph that looked like the one I showed? Yeah? And then you didn't, Natalie? Is this what's in your equation? You didn't use parentheses? That was probably it. Did everybody else get the right graph at least? No?
Yeah, I'm still not getting it.
Does it look like this? Your equations look like that? Okay, so what is your window?
0 to 200 and 0 to 40.
So our X values are a lot bigger than that, so I set mine at 50,000. They don't need to be quite that big. But, so yeah, if you're not getting the right thing, always pay attention to the window sizes if you think you put everything in the equation, or in the Y1 and Y2 right. So did you get it now, Brett? Okay, so who didn't still find the 28,000? Did anybody not?
28.
Braden, do you see how we got that?
Oh, I was right.
Oh, okay. Okay, so yeah, for these ones we just have to find where they intersect. And it happens to be this. So how many half-lives is that? About how many half-lives?
Like 4.9.
Yeah, so almost 5 half-lives.
How do you find that? How do you use that?
So we do, well, nope, that was how we got the first one, but this one we take the number of years. So we do the 28,116.5 and divide it by the half-life years. Remember how 5,230 is our half-life here, so then we do that. So you should get around 4.9. Okay, so I'm going to pass back your test.
Oh, do you want me to go out home? Yeah.
I would, actually.
Bye, Brady. Yeah, shoot.
Why don't you guys both go sit in this common room. You don't need a chair. Brayden, you shouldn't need a chair. You can just go sit in the room in this common
Do I
room.
have to?
Yeah.